Welcome, friends. We are here with the 7th lecture in our course on modern cosmology and physics. Last Friday, Dr. Job Kozhamathadam introduced you to cosmology, the history of cosmology, the paradigm shifts in cosmology, and other historical developments in our understanding of the cosmos. Today, I would like to take you to the modern scientific discussion on the origin of the universe, especially the Big Bang theory. I will introduce this theory, but we have the input from a practicing astronomer himself, probably next week itself, if I am able to cover my portion today. Next Friday, we will have interaction with Dr. George Jacob, who is a renowned astronomer himself, who was instrumental in the discovery of the galactic cluster Saraswati. He addressed our students last year. This year also, he will be addressing you possibly next Friday or Friday after next on the origin of the universe, Big Bang theory, and other scientific details about his own discovery and so on. To set the platform ready for our further discussions in cosmology, we will be switching our discussion over to special topics in cosmology: origin of the universe, end of the universe, cosmic fine-tuning, intelligent design, and exobiology or astrobiology, or search for life on other planets. All these things from an interdisciplinary perspective. We will facilitate dialogue between contemporary cosmology and theological and philosophical perspectives. That is what we are going to do in the forthcoming lectures in this course. Let me share my slide with you on Big Bang cosmology. In the first part of this lecture, I will introduce Big Bang cosmology. And if the time permits, today itself, we will move on to discuss some of the religious implications of this one. Are you sure, did Job deal with steady state theory or mini bang theory in his last Friday's lecture? Can anybody give me a feedback if you recollect?
No, he didn't, Father.
No, okay, fine. Then I will just mention that also. Big Bang is on the center stage since the last 6-7 decades or so. Of course, only with the 1980s, it began to gain greater momentum. Until then, we did not have a scientific account of the origin of the universe. There were only mythological cosmogonies. Cosmogony and cosmology are different. Cosmogony is mostly a mythological account of the origin of the universe. And several religious philosophical traditions have their own accounts of the origin of the universe. Say, for instance, when we dealt with the Indian philosophical system, Hindu philosophy and their scriptures, I had introduced you to the metaphors of cosmic Purusha, the primordial being, or the cosmic egg, the cosmic all-maker, all conveying the idea of cosmic interconnectedness, the organic view of the universe. And not going into the details of that one. Say, before Big Bang, there was a prominent theory called the mini bang theory or the steady state theory. Fred Hoyle, renowned physicist and astronomer, he was the prominent exponent of the steady state theory. Also, an Indian astronomer, Jayan Narlikar, associated with the Inter-University Center for Astronomy and Astrophysics in Pune in India. They were the prominent, and there were many others also, prominent figures in expounding this theory of steady state theory. This also, when Big Bang came up, this was called mini bang theory. Why is it called the steady state theory? According to them, the universe has no origin as such. Of course, since it is before the Big Bang, you can more or less make out as to in which decade. Before the 1950s. In the 1960s also, this was discussed extensively. Universe doesn't have an origin as such, how did the universe come up then? In the beginning, they say, probably an eternal hydrogen cloud, a thick, huge hydrogen cloud. This is in a super dense state. What the universe has is a transition from the super dense state to the super thin state. That is the present state. In the transformation of the hydrogen cloud from the super dense state to the super thin state, galaxies, stars, and planets, and so on have emerged. But where did this hydrogen cloud come from? They're unable to answer that. So they say, this is eternal. It doesn't have an origin as such. This is existing forever, according to them. This goes somehow in connection, in line with the eternal universe, as expounded by Stephen Hawking himself in his no boundary theory. This also, Hawking's theory also we will be discussing eventually. Okay, friends, so only because since there were no reliable scientific account of the origin of the universe, mini bang theory came to be discussed. Otherwise, now it has gone very much to the back burner. Nobody takes this theory seriously. Of course, Jayant, Narlinger, and so on, till recently had been strongly advocating, and they are criticizing Big Bang itself for that. And ironically, I must also mention that the very name Big Bang, you may be familiar with this idea, is attributed to Fred Hoyle, the exponent of the steady state theory. When the Big Bang theory came to be discussed, it is said that he sarcastically, jocularly has been describing the description of Big Bang. Oh, what a big bang. This cannot be true because he wanted steady state theory to be discussed extensively. Later on, this theory came to be named after Fred Hoyle's coinage of the Big Bang in a different sense. But Hoyle has later on clarified that he did not mean anything negative in with this coinage of the nomenclature Big Bang as such. Okay. So before we go on to discuss the origin of the universe, let me give you an idea of the present nature of the universe. I am sure Job will certainly have covered this point with you in a different manner. Originally, we had the Aristotelian cosmology lasted for over 2,000 years, the geocentric cosmology. And the flat space, all those things we had discussed in connection with relativity theory. Then came the Copernican revolution, whereby Earth is no longer at the center of the universe. Then say, until we launched the Hubble Space Telescope, we had thought that everything that we see in the outer space, even with our naked eyes, they are falling under one galaxy, our Milky Way. Only one galaxy we thought of. Now, with the launching of the Hubble space some 30 years ago, more than that, we realized that not even what we see with our naked eyes fall within the Milky Way. Our universe, our galaxy is just among 1 million that is wrong, 1 billion observable galaxies in our particular region. Oh, this is about a particular region of the universe. It is said that 1.5 to 2 billion galaxies must be there in our present universe, it seems. How so gigantic is our cosmos. Okay. And so to help you understand the mammoth size of our universe, let me take you step by step. First, let us begin with Earth. Earth is the planet that we know most. This is 12,200 plus kilometers in diameter, we know. And Jupiter is the biggest planet on Earth, in the solar system. Now, suppose, what analogy can I have? A water bottle here with me. Okay. I have a rather big water bottle here. This is Jupiter planet, and this mouse is Earth. I can place 1,600 Earths over the surface of Jupiter, one next to the other. You understand me, no? If this is Jupiter and this is Earth, I can place 1,600 over the surface of the Earth, like the piggy balls on a big ball. You are familiar with that. So you can understand the giant size of the planet Jupiter then. Then we have 6 more, or including Pluto, 7 more planets and meteoroids, asteroids, comets, many things in this solar system. See, all these things taken together constitute just 2% of the entire mass of the solar system. The rest 98% remains what? The mass of the sun. That is to say, we saw how big the Jupiter itself is. That is the third step. The mass of the sun constitutes 98% of the entire mass of the solar system. Then you can imagine how big our sun is. But you know, our sun is only an average sized star. In a single galaxy, there could be 100 billion stars smaller than sun, of the size of this sun, and bigger than sun also. There are stars 1,000 times bigger than sun. They end up in black holes. We have seen that earlier. Then you can imagine the size of our Milky Way galaxy itself. Our galaxy itself habitates as many stars, giant stars. We are in the outermost spiral of the Milky Way spiral galaxy, our solar system, in the outermost spiral. It is said that if you are to travel to the center of our Milky Way galaxy from our Earth, even if we travel at the speed of light, which is 3 lakhs kilometers per second, it will take 3.2 million light years, it seems, to reach from Earth to the center of our own galaxy, even if we travel at the speed of light. Then you can imagine the size of the, are you able to imagine? I think we cannot. The size of the Milky Way galaxy that we are in. Okay, but to travel to our neighboring galaxy, Andromeda, it takes only 5 million years, it seems, if you travel at the speed of light. Okay, and it is, yeah, here is the right number. There are about 200 billion such galaxies in the universe. Imagine the size of the universe. We started with Earth, then the size of the Jupiter, then the size of the sun, the possible size of the solar system, Milky Way, and the universe with 200 billion galaxies. And another interesting data is that all this that we spoke about, the mass in the universe constitute only 0.01% of the entire size of the universe. That is to say, if we swept together the entire mass, material objects in the universe to the corner of the universe, it takes only 0.01% of the entire size of the universe. What is the rest? 99.99%? It is empty space, interplanetary, interstellar, intergalactic space. And nowadays, informed persons in astronomy speak more about the multiverse. Of course, this is still a conjecture. At the end of this course, we will have some reference to that end of this lecture. And later in our interaction with Joe, Dr. Joe, we can have greater clarity on this point. All what we said is about our universe. There may be several universes themselves possibly coexisting with our universe. That is why no one who has learned the wonders and mysteries of nature, or cannot but marvel at the mystery beneath it. Many scientists have said, no, or that beautiful mystical poem composed by John Glenn from the Apollo spacecraft before seeing the Earth rise from the moon. in the orbit around the moon. Our Earth is a small marble piece. If you touch on one part of it, you should be careful. You may spoil the entire stuff. It appears so innocent, so delicate. We must say, given the gigantic size of our cosmos, our Earth, literally speaking, is not even a grain of sand on a beach. Rob Graffer, no, so who is that? Rob, I don't get his full name. He has NASA and ESA has together published a documentary, highly informed film on Hubble Space Telescope. This is about 2 hours, that film altogether. In that, he is describing symbolically the size of our universe. Suppose, consider our sun is of the size of a sand on a beach. Now, start with that grain of sand on the beach. Walk an entire day, about 32 hours from that sand. It will take 32 hours to reach the neighboring sand on the beach. As far as are the stars in our galaxies. That is the domination of the empty space in our universe. Okay, this will give you some idea about the size of our universe. There are 2 paradoxes about the universe also. It is good to be familiar with 2 interesting paradoxes. Firstly, the size paradox. You know, say here there is a representation of the various of the historical developments in the theories of physics. Newtonian physics, the classical physics is represented with the biggest tall. Then we have the atomic physics going to the bottom of the subatomic world, then to the subatomic world, the grand unified theories and so on. Then we have the smallest size possible in physics, the Planck length, 10 to the power of minus 31 meter, we say. Okay, at that length, that size. See, we said on the one hand, we said the universe is enormously gigantic. On the other hand, we must say it is extremely small in the sense, if we understand matter in its fullest sense at the level of Planck length, we can understand the entire universe. That is why we introduced relativity theory and quantum theory or particle physics in our discussion about cosmology. I said relativity theory and quantum theory are the 2 central pillars of modern cosmology. So with the help of quantum physics and particle physics, that we understand the size of the universe. There is a uniformity to the entire universe. What is that? The mass in the entire universe, it has the same structure. Everything is made up of proton, neutron, and electron, and going further down with quarks, leptons, and forces. That is what the basic structure. And this is what the physicists are struggling to understand at the Planck level. But that still evades the understanding of the scientists even today. We do not fully understand. We had to discuss the philosophical implications, the uncertainty principle. Such concepts you may kindly recollect in this context. We cannot understand matter in its smallest size. So this is what the first paradox. If we understand matter in its smallest size, we will understand the full nuances of the gigantic structure and nature of the cosmos. Second paradox is the time paradox. What is that? The time paradox. Say, according to latest findings, our universe is 13.76 billion years old. 13.76 billion. In Indian terms, 1,376 crores years old. Okay, but and how long the universe is going to be? We can, as of now, we do not know the exact future of the universe. But we can know the full history of the universe as well as predict the entire future of the universe, provided we know what happened in the very first second in the history of the universe. Go back in time, go back to the first second, not even the complete first second, 10 to the power of minus 42 microsecond of the first second. Only so much you need to know. But what happened between the absolute zero and the 10 to the power of minus 42 of the first second, scientists do not know. That is why absolute origin still remains in mystery in physics today. The more we understand, the more mysteries are opened up in cosmology also. Okay, this is not a speculation. This is not my original idea also. Who else? I think I can give you the reference later as to where is this idea of paradox is discussed. Okay. So now, how do we learn about cosmos? Maybe Job had have covered something about this also. Mostly based on optical, how do we understand the origin of the universe? Basically based on optical astronomy. We study cosmic radiations. Okay, that we will explain with regard to our discussion of the proofs of Big Bang theory. Now, a new window also is opened in cosmology, that is gravitational wave astronomy. When I introduced you the discovery of the gravitational waves, I had introduced this concept. Light originated only 300,000 years after the Big Bang. So optical astronomy could not go beyond 300,000 years history of the universe. Now, gravitational astronomy can take us literally to the beginnings of the absolute zero. But this is a branch of astronomy that is in the making. We will have to wait further to get more information. Future of astronomy is possibly in gravitational wave astronomy. Okay, let us switch over. Do you have any questions about what we have discussed so far regarding the size of the universe and the paradoxes? If you wish to clarify anything, you can stop me anytime and or put it in the chat box. Okay. What is the Big Bang theory? You know, in layman's language, we said this is an initial explosion. But this is not like a firework, this explosion. There was no huge sound to be produced out of Big Bang. Normally, this is how animations and documentaries and so on doing. But that is to catch the attention of the viewers. Otherwise, in the beginning, the entire matter that we see in the universe was condensed in a small region of space. Let us say the entire matter that we observe in the universe today, it was all compressed into an infinitely small, not infinite, into a small region of space. Let us say, for understanding's sake, we say of the size of a coin, but that's a poor analogy. A better example would be of the size of an atom. The entire universe was of the size of an atom in the beginning. All the matter that we see in the universe was condensed in that small atom in a different stage. It did not have even the size of an atom. It had the size of a nucleus. No. It was as small as a subatomic particle like quark. Let us believe so. But better to say, it had a zero size. Then the question comes, how could something be in zero size? No volume. That is why Big Bang is always called a singularity. What's the meaning of singularity? A couple of times we have referred to it. Singularity means a point of limit or boundary where all the currently known laws of science will be breaking down. A point beyond the contours of the present developments in science. Something that cannot be understood by present theories and laws of nature. Okay, that is what's called a singularity. Big Bang is such a singularity, existing in zero time, in zero size, but infinitely dense and infinitely hot. And that matter soup is the phrase coined by Heinz Pagels in his popular bestseller, The Cosmic Code. I liked his metaphor, the matter soup. Okay, and that matter soup exploded. What happened? The explosion, how did it happen? As I said, this is not like a firework explosion or a bomb explosion. Then a slight change in the energy level of this matter soup. What's physicists call a quantum fluctuation. That sets the matter soup in expanding mode. As it began expanding, the size began to increase, density began to decrease, temperature began to decrease. Originally, in the very first second in the expanding phase, the elementary particles were formed, what we discussed in quantum physics, quarks, leptons, and gluons. The first four fundamental forces of nature were created in the very first second. Gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Then the lighter elements like hydrogen, helium were formed after the first second. Then the first 3 minutes are said to be the most crucial period. Then comes the 300,000 years where matter, radiation got decoupled from matter. Then by the time the universe was 1 billion years old, it is said that the first galaxies were formed, the quasars and so on. But now the latest data from the James Webb telescope says, when the universe was just 4 million years old, probably the first galaxies must have been formed. So every day our knowledge is being refined and updated in cosmology. And James Webb telescope also has found several inconsistencies with our present theories and observations about the cosmos also. So many things will have to be revised with the more data from James Webb telescope. Those details we can update from the scientist himself. Okay, so what is there? If something is there in the chat, let me see. Does the emergence of life after the universe contradict the creation narrative in the Bible? How do we reconcile the two? Thank you, Steve Sheets Wangra, for that question. But certainly, this is a theological question. We will, in detail, we will discuss this question. It is to discuss such points that we are introducing the science of Big Bang here. So it in no way contradicts the biblical account. There are areas of dissonances and consonances. How should we understand the biblical account of creation? Please recollect what Professor Matthew told you. We had two theological inputs on understanding creation narratives in Bible. We may not be able to discuss all in detail here today, but certainly next or week after next Friday, we will be discussing it. So there is no contradiction between the creation of light and the Big Bang account, but complementarity is not at the literal level, not to be intersected both on the same footing. It is in terms of the message of the creation narratives that we find a complementarity between Big Bang and the biblical account of creation. Okay, so kindly hold your question. We will take it in detail. Okay, the major exponents of the Big Bang theory are George LeMaitre, a priest of the Brussels diocese. He was the professor of astronomy in Leuven University in Belgium. Also, Russian mathematician Alexander Friedman. And the term was first coined by Fred Hoyle, as I said in the introduction. And George LeMaitre, while he was working on Einstein's general relativity, it occurred to him that if this is the state of affairs, it is theoretically possible that the entire universe must have originated from a single point. And he developed the mathematics for that. And that single point must have evolved into the present universe. He brilliantly developed the mathematics for that. And he discussed this with Einstein himself. Einstein, having gone through his paper, said, "Your mathematics is wonderful, but your physics is abominable." Abominable, something very strange. That is to say, Einstein could not digest the idea of a single universe, the entire universe originating from a singularity and expanding from that, and that expansion even continuing now. Einstein could not have been comfortable with that. His own theory implied the expanding universe. Einstein's relativity theory, mathematically, implied the expansion of the universe. But Einstein is often termed as the last classical physicist. He always opposed quantum theory, His worldview had been highly classical, although he pioneered the new physics. Classical physics had the view of a static universe, not an expanding universe. Hence, in order deliberately to withhold the expansion of the universe, Einstein introduced a mathematical constant in his calculations called the cosmological constant. Okay, with the help of this introduction of the cosmological constant, Einstein avoided the expansion of the universe in his general relativity theory. 20 years later, who is that? Here is Hubble. Edwin Hubble, through telescopic observation, found that the universe is expanding. Einstein himself watched the universe, made observations through Hubble's telescopes. And then he said, the postulation of the cosmological constant was the biggest blunder of my life. Einstein was humble enough to acknowledge that. But later on, nowadays, with the discoveries of dark energy and so on, Einstein's Hubble cosmological constant is again discussed in astronomical circles. Okay, so Alexander Friedman and George LeMaitre, they are the two major prominent first exponents of the Big Bang theory. It has undergone series of developments since then. They only provided the initial equations for that. Okay. We can compare the expansion of the universe to the inflation of a balloon. Imagine a balloon with dots over it. As you blow the balloon, the distance between the dots will be increasing. What do these dots stand for? Dots represent galaxies. As the universe is expanding, every moment the distance between galaxies are increasing. All galaxies run away from each other. But it should be noted that within a single galaxy, there is no expansion. The distance between Earth and Mars, it doesn't increase. But the distance between galaxies, there is increase. And that is so. This is now the question. You see in violetish color, you see my balloon on my screen, computer screen. Now, what is there outside that balloon? It is white empty space, is it not? Does anybody would like to give me a feedback as to what is there outside the balloon? Considering universe to be the balloon, what is there outside the universe now? Of course, you may be thinking that there is space outside. Universe is expanding through space, is it not? But here is the correction. Expansion of the universe means expansion of space and time. If the universe is expanding through space and time, the question comes, where did space-time originate from? Did it originate before Big Bang? I will make a correction later on. But as of now, you may understand, going by your conventional understanding of Big Bang, space and time originated only with the Big Bang. Therefore, the origin of the Big Bang expansion is not an expansion that is happening through space. So what is there outside the balloon or outside the universe? Nothing. Nothing is not a thing. We cannot imagine even nothingness. There is no outside to the universe. Inside and outside are properties of space. How far the space has reached now? That is the boundary of the universe. There is no outside to the universe. Then the next question. Does our universe have a boundary then? Yes, our universe has a boundary, but that is not a static boundary, but a dynamic boundary. That boundary is always expanding. Okay, that is what the conventional Big Bang theory is telling us. So this is another representation. It all begins with a sudden flash of light, beginning with the Big Bang. Then proto-galaxies being formed, then distance between galaxies formed, galaxies are expanding and running away from each other. No, sorry, not galaxies are expanding, but universe is expanding. So this is singularity, just a recapitulation of all what we discussed. Singularity is a boundary or a point of limit where all the laws of physics break down. The beginning of Big Bang is considered to be a singularity in science. Black hole is another singularity. Wormhole is another singularity. Say I find there are 20 participants, 20 persons attending this lecture now. I am placing 20 of you in 20 galaxies now. Let us sit in 20 galaxies now. Let us catch one light ray in each galaxy. The cosmic light ray that originated from Big Bang. Let us catching this light ray, let us go back and back in time. Finally, all of us will reach at that single point in time. That point is technically called the T is equal to 0. T stands for time, when time was 0. So Big Bang singularity is technically called T is equal to 0. Infinite pressure, infinite temperature, infinite density, 0 size. Okay, here we have a history of the Big Bang, but maybe going a little more technically into the Big Bang discussion. See, here is the history of the universe. See, Big Bang, T is equal to size is 0. As I already told you, the first second is the most crucial period in the history of the Big Bang. Let us split the first second into various segments. According to physics today, the most scientists more or less understand all that happened in Big Bang, beginning with 10 to the power of minus 43 microsecond in the first second. And what happened between the absolute 0 or the T is equal to 0 and the 10 to the power of minus 43 of the first second? Quantum effects, laws of physics unknown. We do not know even now. Remember, in quantum theory, there was a point saying the primacy of uncertainty principle. There is a fundamental uncertainty to the universe. Probably this is there evident in Big Bang as. Then, in the first second, when the temperature was 10 to the power of 27 degree Kelvin, time 10 to the power of minus 34 seconds, quark and anti-quark dominated epoch. The first one was super unity, where all fundamental forces were one. This is that I will explain later. Okay. Then comes temperature 10-15 degrees Kelvin, 10 minus 10 seconds. In the first second, what happens? Formation of protons, neutrons, mesons, quarks, and now the universe is 1 second old. Protons and neutrons bind together as nuclei of hydrogen, helium, lithium, and deuterium. When the universe is just 1 second old, the lighter elements of hydrogen, helium, lithium, and so on were formed. The nuclei were formed. Electrons are still get bound to them. Okay. Now, the 3 minutes, what happens? Matter and radiation, photons are formed in the universe. But that photons are not free. Matter and radiation are coupled together. The matter density is so thick that photon particles cannot travel freely through the Big Bang matter soup. Therefore, if at all you were existing before Big Bang and you wanted to see Big Bang explosion, you will not be able to see Big Bang because this is taking place in utter darkness. Because there was no photon particles being free to travel through the expanding space, given the density of space. If God needs light to see things, I must say God also has not seen Big Bang with his eyes. Then, good news. By 300,000 years, for the first time, we can see the universe with the help of light. Here, matter and radiation decoupled. The universe becomes transparent, and the cosmic background radiation is able to travel freely through space from 300,000 years old. It is where optical astronomy begins, studying cosmic radiation with the help of ground-based and space-based telescopes, 300,000 years. So the time before that, the new window for astronomy is gravitational wave astronomy, the new branch of astronomy. So 1,000 million years, that is 1 billion. So you must excuse me for this old data. I must say, as I told you earlier, James Webb has corrected this idea. 400 million years ago, possibly, the clusters of matter form quasar stars and proto-galaxies. Okay, now, as per the old data, the universe is 14 billion years old. Now, the accurate data is 13.76 billion years. Okay. Now, what happened in the first second? The separation of the four fundamental forces of the universe. In dealing with the particle physics and quantum physics, I had introduced you to the four fundamental forces, namely gravitational force, electromagnetic force, and strong nuclear force and weak nuclear force. Strong gravitational force is responsible for the equilibrium of the universe. Why Sun and Earth are not colliding? Why galaxies are not colliding against each other? Because they are held in equilibrium by gravitational force. Electromagnetic force. Why my hand is not running away from my body? Because all particles have electromagnetic force. They bind the objects together, atoms together. Okay. Strong nuclear force. Proton and proton have the same charge, positive charge. Similarly charged particles should repel each other. So protons must keep themselves as far as they can. But in the small region of space in the nucleus of the atom, they are bound together. That force, binding force, must be very strong. That is why strong nuclear force is called strong nuclear force. And weak nuclear force is only another aspect of the electromagnetic force. Okay. So in the beginning, in the Big Bang, all these four fundamental forces were in a single form. There was only a single force in the original Big Bang until the first second. Firstly, in the first second, the gravitational force got separated, the breaking down of the symmetry of the universe. Universe was a perfect symmetry in the Big Bang. Now begins the symmetry breakdown. Then electromagnetic force got separated, strong nuclear force, weak nuclear force. Now, when we discussed particle physics, I had introduced you to the idea of the grand unification in physics. This is the ultimate dream of physics today, the unification of the four fundamental forces of nature. This is what they are aiming at as the GUT, grand unified theory, M theory, mother theory, F theory, father theory, relativistic quantum theory, super gravity theory, and so on are some recent candidates for this GUTs. Until today, scientists have succeeded only in combining together both electromagnetic force and weak nuclear force. It remains a remote dream. Stephen Hawking had predicted the end of physics by the year 1980. He said the four forces will be combined by 1980. A theory of everything will be developed. That will be the end of physics. It did not end. Then he extended the deadline to 2000. It did not end. The more we know the mysteries of physics, more complexities are only evolving. So it is not as simple and naive as some of these physicists are naively presenting. We should understand. Okay, forget about this one. This is already, at this point, I've already covered. This is only another way of presenting it likewise. Some proofs for the Big Bang theory. These are the dominant proofs for the Big Bang theory. In 1920, the Hubble expansion or the Hubble's constant, Edwin Hubble found that every galaxy that is observed is moving away. This is related to the concept of the Doppler shift. Hubble's constant, the precise value of the expansion rate is called the Hubble constant. The Hubble's law is that the more distant a galaxy is from the Earth, the faster its recession velocity. The galaxies nearer to us will have slower speed. expansion rate will be higher for the galaxies farther to us. Okay. This is called the Doppler effect, that is normally applied to the sound waves. If an aeroplane is approaching us, the frequency of the sound waves will be more, and we will hear sound in intense voice. Intense voice will be heard. If it is moving away from us, frequency will be less and the sound will be feeble, we know. Similarly, the same principle can be applied to light also. Light consists of 7 colors, we know, with GR. And each color has got its own wavelength. And suppose a source of light is moving away from us. First, we will see it in blue color, green color, yellow, orange, red. Same color, but appearing in different colors, depending on the distance. Okay. Now, suppose a distant source of light is coming towards us. First, we will see it in red color. Then finally, orange, yellow, green, finally in blue color when it reaches us. Okay. This is the Doppler effect. This is exactly the principle that Hubble also used in explaining the expansion of the universe. The precise expansion rate is called the Hubble's constant. Now, I must also add another point here. See, it is said that probably Hubble was influenced by Lemaitre, the original exponent of the Big Bang theory, in developing this Hubble's constant, it seems. Lemaitre published his original paper in Flemish, his mother tongue. But that did not catch the attention of the mainstream astronomers of that time, because very few were competent reading in Flemish. However, Hubble happened to go through his paper. Hubble translated his paper into English, and some allege that Hubble deliberately bunked translating one paragraph from Lemaitre's paper, it seems. And he made some modifications to those calculations of Lemaitre and adapted that into his paper in which he developed the concept of the Hubble's constant. That is why Hubble's constant was named as Hubble's constant. However, International Astronomical Society, which consists of about 6,000 members from all over the world, conducted a survey among themselves. A referendum was made. What about renaming the Hubble's constant as Hubble-Lemaitre constant? I think it happened about 6 or 8 years ago. And 74% of the astronomers agreed that Hubble's constant can now be renamed as Hubble-Lemaitre constant. Therefore, now this is called as the Hubble-Lemaitre constant technically. Okay, that is the first proof, the detection of the observation of the expanding universe. That is the first, one of the most convincing proofs for the Big Bang theory. Why my slide is not okay. So these are some Hubble images of the deep space, the boundaries of the space. Each dot that you see on the screen refers to a galaxy, basically. And what do we see in red color? This reflects the redshift of the galaxies. Okay. The second proof concerning the Big Bang is the detection of the cosmic microwave background radiation. That is to say, the proof for the Big Bang theory is there in each nook and corner of the universe. On our bodies, on my tongue, there is this proof for Big Bang theory. What is that? The cosmic microwave background radiation. That is to say, the radiation originating from the original Big Bang is there all over the universe even today. The original temperature of which has been infinite at the beginning is now just 3 degrees Kelvin hot only. In 1965, in Bell Laboratory in Berkeley in California, the scientists happened to detect cosmic microwave background radiation by chance. They heard a steady hiss in their experimental setup. They eliminated all potential sources of this hiss sound, but they could not avoid this sound. Finally, they consulted it with some renowned astronomers, and they said probably this is cosmic microwave background radiation. And further experiments confirmed that this is the detection of the cosmic microwave background radiation. This is very uniform all over the universe today, this background radiation. That it is uniform all over the universe mean that it all originated from a common source. So this accelerated the discussion on Big Bang theory. Then when Big Bang was not receiving adequate scientific support and experimental evidences, this discovery gave a big boost to the Big Bang theory. Okay, this is the example I told you about sitting in different galaxies and going back to the origins. Of course, it will not be a linear passage because space itself is curved, Finally, we will raise time itself is in this shape, a kind of pear-like shape time also has. We all will reach in Big Bang when T is equal to 0. And the most convincing proof for the Big Bang theory came in 2016, I think. What is that? The Wilkinson's map, W map. What is this W map? Based on their theories, scientists constructed a theoretical model of the early universe, of the baby universe. When our universe was just 300,000 years old, how the matter might have been distributed all over the space, and what should have been the size of the universe, shape of the universe, all those things they theoretically estimated. And they prepared a map. But in science, nobody will be content with just theoretical predictions. We need experimental evidence. So in order to check whether their calculations are correct, scientists send a satellite to the space named COBE, Cosmic Background Explorer. Okay, Cosmic Background Explorer. What did it do now? It was there in the space for about 10 years, and looking at the remotest boundaries of the space, looking at the beginning of the 300 years old universe, it took photographs and assembled them together. And that map is called the Wilkinson's map or W map. And the observational evidence 100% corroborated the theoretical model. That's why I said this is the most convincing, imposing proof for the Big Bang theory. Okay, the COBE explorer. This is the picture of the 300,000-year-old universe. When our universe was just 300,000 years old, it was having this shape and this size. No galaxies. We find only some colors or something like paints or dots there, no? An informed astronomer can publish 1,000 research papers from each square inch of this graph. Okay, this is the shape of the space also of the early universe. And this is the satellite which took the photograph of the infant universe. Okay, and this is the first picture of the outer space or the boundary of the universe from the James Webb Telescope. I hope you are familiar with the launching of the James Webb Telescope. Hubble Space Telescope was about 600 meters above the Earth. Whereas, you know, James Webb Telescope is 150,000 miles away from Earth. It is revolving around the sun, not around the Earth. This in such a particular. That is why we have much more sharper, clearer information about the universe with the James Webb Telescope. There are some comments in the question. Let me see what. The Earth, which is part of the Milky Way, is moving as a galaxy as a whole. Yeah, Christopher, your understanding is right. Earth is moving away with the Milky Way galaxy, not within the Milky Way galaxy. Our Earth is not moving away from other planets. We are not in the same position we had been yesterday in the universe. Our Earth is not in the same space in the universe where we had been yesterday, because our Milky Way is running away. So galaxies are running away from each other, but within galaxy, there is no running away of planet sense or stars. That point needs to be clear. Okay. Then one more point, the inflationary universe. But you know, friends, if you ask an astronomer today, what is the origin of the universe? What is the scientific theory concerning the origin of the universe? We will immediately shout out, say, Big Bang theory. But informed astronomers will say it is inflationary theory. What is inflationary theory says, no? This is another interpretation of the Big Bang theory. Now, there is a big problem with this Big Bang theory. If Big Bang theory is correct, if there are as many stars and so on in the universe, the darkness of our night, the darkness of the night sky cannot be accounted for. If there are so many stars in our own galaxy, our night should not be that dark and deep. Although our sun might set, lights from other stars should be lightening our Earth, but it doesn't happen. Why is that? Big Bang theory cannot explain that. One possible explanation is given by Alan Guth's inflationary model, which says our universe is much more enormously gigantic than what we are accounting for in Big Bang theory. That is possible because in the very first second in the history of the universe, in the first phase of the expansion, what had happened probably is super rapid exponential expansion. Exponential expansion, what is that? Exponential growth, what do we mean? 2 becomes 4, 4 becomes 8, 8 becomes 16, 16, 32, 32, 64, likewise. Doubling in size in each instance. Okay, probably between the absolute 0 and the first second, the universe must have expanded in a heavily accelerated rate. If that is the case, that is why it is called inflation of the universe. Inflation, you know, is bulging out, expanding out, stretching out. Therefore, in the very first second, the expansion must have been taking place at an extremely high speed. If that is the case, the universe must be very, very gigantic. If it is so, the distance between the nearest stars to us must be farther than what we can conceive of. Therefore, light may not have had enough time to reach us to light our night skies. Okay, therefore, inflationary theory is more or less accepted in present-day astronomy. That is the idea of inflation. See, what is inflation? The basic idea is this. At an early phase in the history of the universe, it is suddenly expanded in size. There are several other implications also for inflation theory. We will avoid all scientific technical details. Just in layman's language, we will try to understand this. See, this looks like mountains, no? But no. This is the skin of the balloon, which we discussed at the beginning. It is not a smooth surface that our balloon has if inflation theory is right. At a different regions on this space, boundary space on the edge of the universe, there may have been different expansions taking place. Different regions of space getting inflated because of false vacuum energy in different sizes. If that is the case, what can happen? The surface of our balloon universe is likewise, which would mean each of this inflation that we see on the surface of our parent universe can result in the formation of a baby universe. That is to say, a baby balloon may pinch off from the quantum skin of the parent universe. A baby universe can be originating from the parent skin of, from the skin of the parent universe. Laws of physics permit that. This is what led scientists to think of multiple universes, the existence of multiple universes. Where are these multiple universes? They are connected by wormholes. Are they in our own space? We do not know. We have only speculations. Multiple universe theory, although scientific community is seriously speaking about it, and many are well convinced about that, this is still not a well-established theory. Some consider it a hypothesis. Some consider it still over as a conjecture only. Anyway, this is seriously discussed. Stephen Hawking and so on were advocating multiple universe conjecture. He says they may be connected by wormholes. Wormholes I had introduced you in my discussion of physics, where time is traveling backward, shortcuts between distant regions in space. Okay, so multiple universes may be coexisting with our, not necessarily outside our universe, within the space of our universe itself, in higher dimensions. These universes can be coexisting. Okay, I have a glass of water. Let me take a glass. I think I already said this analogy to you. Say there is 100, this glass is full. I am drinking water from it. I half, only 50 milli remains now. That also I consumed. But I keep on drinking from this glass. I pour water into this glass. Glass is now full. I keep on pouring. You might think that water must be overflowing from my glass. In three-dimensional space, it will. But in multi-dimensional space, which may be 9 dimensions or 11 dimensions or even 100 dimensions, as hypothesized by some physicists, the water will not be overflowing from this form. An entire ocean can be contained in a single glass in a multi-dimensional space. Okay, so in order to convey this idea and understand as to where it is all, basically, I only gave you this kind of confusing examples. We had discussed this point in our discussions on physics. Now the question is beyond the first microsecond. The question is, where did the Big Bang come from? Of course, here also my focus will be on science. We may not get time to do the theological discussion today, but certainly next week we will follow it up. It's what the scientists, where did the Big Bang come from? One old interpretation in the early 2000s and in the 1990s and so on, the old interpretation was that it all came from nothing. What made scientists to think that the universe came from nothing? No, because if we add together the total energy of the universe, it amounts to almost zero. What is the total energy of the universe? In the energy bookkeeping of astronomy and physics, two kinds of energy, positive energy and negative energy. The energy of the entire mass in the universe is considered positive energy. Now, the expansion of the universe, since an external energy is needed for the expansion of the universe, this is considered as negative energy. Now, if you add together both the positive and the negative energy, you get almost zero. This was the old idea. Therefore, which means the total energy of the universe is almost zero, which means the universe originated out of nothing, came from nothing. But this is the old thinking. Nowadays, physicists do not consider this idea to be anything because the very idea of the amount of mass in the universe has undergone change significantly. I think Joe might have told you, or we will come to that eventually when we deal with the end of the universe. The visible matter that we see in this 200 billion galaxies constitute just 3.6% of the entire mass in the universe. All 200 billion galaxies and the hydrogen clouds, out of which galaxies are formed even now, they constitute only less than 4% of the entire mass in the universe. The rest is dark matter and dark energy. When we were discussing this negative energy and positive energy, scientists had no idea of dark matter or dark energy. Now, then where did the Big Bang come from? What is the present idea? Ultimately, first one point I must clarify to you, that is to say, one debated point in cosmology today is that how far science may advance, the ultimate origin of the universe may remain shrouded in mystery forever and ever. We may not come to know the absolute origins of the universe, it seems. And these scientists are arguing based on three reasons. First one, Heisenberg's uncertainty principle, which we discussed in quantum theory. Sorry for these technicalities. You can ignore these scientific details. But this is the point. We may not be able to come to know the ultimate origins fully. The point is this. I have a piece of paper here before me. I am writing the letter A, B, C on this piece of paper. I am giving this paper to you. If you can read the ABC on this paper fully, you have understood the ultimate origin of the universe. But I tell you, friends, given Heisenberg's uncertainty principle, you will never be able to read ABC together. What is the reason? Because if uncertainty principle is true, applying it to Einstein's relativity theory, you will never be able to read ABC together because you do not have see the ABC as a whole, but as 1 million pieces. You will not be able to put them together and read ABC. That is the real original information about the origin of the universe is completely erased from the universe by the laws of physics itself. That is what uncertainty principle implies. How now? I'm going by Einstein's relativity. You know, Einstein's general relativistic understanding of black hole, gravity, curved space, mass curves the space. In the Big Bang, each particle has been as massive as the size of a galaxy. No, as the weight of a galaxy. Each particle, since the Big Bang matter source contained the entire mass in the universe, each particle that was formed in Big Bang had the mass of a galaxy something. That was able not just to curve the space, but to tear apart the space-time fabric altogether in the Big Bang matter source. Relativistic understanding of gravity. Therefore, the entire information of the space-time information must have been completely torn apart, given the laws of physics then. That is why the third option, multiple universe. Let us look at the third option first. Multiple universe. If the multiple universe conjecture is true, we will never know the ultimate origins. Why? Let us take the example of ABC. I am giving ABC to you. If you can read ABC together, you are understanding the universe fully, origin of the universe fully. But I tell you, you will never be able to read ABC together. Why? Because it is not just one ABC that is given to you. Hundreds of ABCs are given to you now. Hundreds of original universes are given to you now. You are picking up one ABC and say, I have understood the origin of the universe. No. You are going to a forest of pine trees. You are touching one pine tree and say that this is the pine tree. What about the rest of the trees? When we say about the origin of the universe, which universes, of which origin are we speaking about? Of which universe are we speaking of? These questions are happening, occurring. Okay, that is the problem with the if multiple universe conjecture, ultimate origin will never remain shrouded in mystery. Then, third possibility, third argument is from the inflationary model, which we already discussed. We said in the original moment, the universe must have inflated at an extremely high speed. If inflationary model also is right, we will never know the origin. Why? Let us take the analogy of the ABC. I have written ABC on this paper. If you can read ABC together, you have understood the origin of the universe. That is our contention, no? I say you will not be able to read ABC in the inflationary model. Why? Because the universe is enormously big in size. You will not see ABC together, let alone the single letter A, because only one fraction of the first lining of the letter A will you see on the written paper. Okay, you will not be able to read ABC together. That is the idea of inflation and uncertainty. So the ultimate origin remain shrouded in mystery. This is the present day thinking. But I must also add one point as to where did the Big Bang come from scientifically? What the present day astronomy tells us today. This is from here. You see the picture there, no? I had already introduced this to you in our discussion of particle physics. Beyond the quarks, leptons, and forces, you find something there, Higgs boson, and beyond that, the Higgs field. In the beginning, there was the Higgs field, the energy field. And that energy field might have turned out to be a Big Bang. Here, there's a slight modification to whatever I have been discussing to you. I said that space-time originated with the Big Bang. With the confirmed discovery of the gravitational waves, the present-day understanding in science, astronomy is that possibly space-time originated before Big Bang. not originated, probably space-time is eternal, or probably space-time existed before Big Bang. Big Bang is possibly an event within space and time, because possibly Big Bang originated out of the Higgs field, which is an energy field. For this energy field to exist, there must be space and time. Okay. In the beginning, there was the energy field. Out of this energy field, Big Bang originated. That is what the standard model of particle physics and Big Bang cosmology is telling us today. And there are further detailed explanations for this. I am not able to go into all those details. My own understanding is limited. Possibly in our interaction with the scientist himself next week, for those of you interested, you can have further discussions. And there are many more things we have got to say about the science of Big Bang also. I am not going into those details. With this, I am concluding my discussion on the science of Big Bang. Then we will pick up the philosophical, religious, and the biblical scriptural interpretations of or appropriations of the Big Bang. Possibly next Friday we will do that. Now, we have about 5 minutes left. You are free to come up with your questions and clarifications and comments also. Anything that is not clear, I am glad to clarify that also. And it has all been there in Big Bang. And now science is telling us it all originated from an energy field itself. If you can anticipate something of the theological reflections that we will be doing later on next week, Gregory of Nyssa has said that matter is energeia deo. Matter or mass is God's energy. Big Bang is the condensed energy of the divine, one way we could say. So we said it all came from the Higgs field. Of course, science, particle physics cannot go to God. It can say that in the beginning there was an eternal energy field. That must be an terrific energy field, as you are estimating the incredible depth of energy in the universe. Then that is in a way a glimpse into the marvels of the divine, we could say, divine energy. And you are finding a practical application in love also. Very fine. Thank you.
Thank you.
Anybody else? Bishop Peter, you wish to say something?
Yeah, I was saying that when you come to simple, the Bible says, in the beginning, there was. So I would like to say, in the beginning, or before the beginning, there was energy.
Yeah,
there was that energy that you are talking about. And that energy, and God said, let there be. So that energy produced what you have talked about all the way through. It's a question. Yeah, so I would say you are right. It's you cannot understand it. You said we cannot really grasp it forever. But which is this beginning? The universe. You say the beginning of the light. So I'm seeing it in that perspective. Instead of using the biblical terminology and all that, I'm seeing it now with these terms.
Wonderful. You are able to see the science in biblical perspective. That is great.
Yes, I'm seeing that. So we can expand it later on.
Appreciate your attempt, Bishop Peter. And when we discuss theology and biblical appropriation, certainly we will do more of these things will become clear about that. That's why I said, as far as the message of the Genesis account of creation is concerned, Big Bang perfectly complements the scriptural understanding. But as the creationists do, if we do go for one-to-one correspondence between the scientific and biblical narratives, literally, it is completely opposite. Then thank you, everybody. Thank you for your patient attendance, and thanks for the positive feedback you have put in the chat box also. We will meet next Friday.